Hey guys, today we are discussing about two topics, why C programming and journey of a C program. Let's start with it. Just remember one thing, before you learn anything, just ask yourself the question why. Why you are learning it? What made you to learn it? What is the need of it? Okay? Today we are discussing about C programming, right? So let's dive into the why question. Computers are very powerful. They don't understand our normal human language. They can only understand binary language. And this binary language will be in zeros and ones. So we need a language that helps us to give instructions to the computer so that computer should understand those instructions and it should execute them. That's where programming language comes into the picture. And our C language is a programming language. This C language acts as a bridge. It acts as a bridge between humans and computers. Here we are discussing about this programming language. But you should have a small doubt here. If computers can only understand binary language, why we are talking about programming language? How can a programming language gets understood by a computer? In order to get answer for that question, we should dive deep into the concept of journey of a C program. Our journey of a C program starts with a source code. This source code is nothing but our simple C program. Let me write a small C program. Here we have some statements starting with hash. These statements are called as preprocessor directives. So what are these preprocessor directives? These are certain commands, okay, that instructs this preprocessor to perform specific actions. And remember one thing, all the preprocessor directives start with hash symbol. Every preprocessor directory have its own use case. For example, hash define is used to define a macro. Here pi is a macro. A macro means simply a constant, okay? A constant variable. And hash include is used to include a file into our source code. We will get to know them deeper in the upcoming steps. This source code is given to preprocessor. The duty of a preprocessor is to handle the preprocessor directives, means the statements which begin with hash and then removing comments. In our program, we don't have any type of comments, so this step is skipped. But handling the preprocessor directives means what? Here we have two preprocessor directives. First one is hash include stdio.h and second one is hash define pi 3.14. Here what preprocessor will do is it will simply include this stdio.h file into our source code. In the entire program, if it encounters the word pi, it will simply replace the word pi with 3.14. So after preprocessor handle these two things, the preprocessor code will be looking like this. We will be having content of stdio.h header file, and then after that we will be having this source code again, but here this pi will be replaced with 3.14. Two things were handled here. First one is the content of stdio.h header file is placed above our source code, and then the word pi is replaced with 3.14. So it is our preprocessor code. And then this preprocessed code is given to compiler. The job of the compiler is to check for errors and to translate. What is this translate means? Translation means converting a set of instructions from one programming language to another programming language. Compiler is translating our preprocessor C code to assembly language code. This preprocessor code is converted into assembly code by the help of compiler. This assembly code is a low-level CPU specific code. It means each C statement is broken down into simple CPU instructions. For example, those instructions will be like move the value of R1 into register R2 and add the value of R1 and R2 register. These are CPU specific commands, but yet it is not the complete machine code. It is like a bridge between our C language and the machine code. This machine code is simply our binary code. Okay. To convert this assembly language code into this binary code or into this machine language code, we will be giving this assembly code to assembler. This is assembler, and the job of the assembler is to convert assembly language code to machine code or binary code. So this code will be completely in zeros and ones. I will show you a small example. Let us suppose this is our assembly code. Okay, it is not the specific assembly code for our given source program, but just consider it as an example. So this assembly code will be converted into a binary code only with zeros and ones, and this move will be converted into this something like 101111, and the rest of the part will be as like this. And similarly, that add is converted into something like this, and also the remaining part will be like this. So everything will be in zeros and ones in machine language code. Now we have got object code, and here we may think that our job is completed. We may think like we successfully completed our C language code into a machine language code, but our job is not yet completed because there is a small concept here. Here in preprocessor, it is loading all the content of the stdio.h into our source program. But what is the content of that stdio.h header file? I will show you that. The stdio.h files only contains declarations of predefined functions. It means we have many predefined functions like printf, scanf, puts. These all functions are stored in stdio.h header file, and this header file will only contain the declarations. Like it will just say, okay, I have these functions in me, but I don't know the body of those functions. I don't know what that functions contain. I just have their name. That's it. When we give this entire program to a computer along with the declarations, we should also give the body of those functions so the computer can understand and execute that particular instruction. Okay, where is the complete body of those predefined functions located? The body or code for these predefined functions is located in a standard C library called as libc or msvcrt.lib. This libc is for Linux. It's for Linux based systems, and this is for Windows based systems. So these are C libraries, and these libraries will contain the final binary code of those printf, scanf, putf, and all of these predefined functions. Somehow we need to bring the library code into our code. So for that purpose, we are using this linker. This linker is a program that combines object code of your source program and the library code. In our program, we are using this printf function. The declaration for this printf is located in stdio.h. That is okay. But the actual code of the printf function is not located in stdio.h. It is located in these libraries. So linker will combine our object code with that library code and produces a final executable file. And this is our final file, and it is in binary language. So this file contains everything that a computer should understand. Now we successfully converted our C program file into a complete full-fledged binary file. But still there is a small final step that is pending. Just remember one thing, to execute any file, okay? To execute any file, it should be located in our main memory. Where? It should be located in our main memory or simply RAM memory of our computer. So, who will keep this executable file into this main memory? This fellow loader will keep our final executable file into the main memory so that computer can easily execute it. This is the journey of a C program from a very beginning source code to the final binary file. If you have any kind of doubts, please comment it down. And also if you have any suggestions, I'm happy to hear. Thank you.